Hello and welcome everyone. I'm excited to present today on understanding the power of machine learning. My name is Swapnil Sauraf, and over the next few minutes, we'll explore what machine learning really means, how it's being used in the real world, and what kind of career opportunities it offers. Whether you're a student, a working professional, or someone curious about AI, this session will give you a practical and inspiring overview. Let's begin with a thought provoking question. Who are some of the largest companies in the world today? Amazon is the world's largest bookseller and retailer. Uber operates the biggest taxi network without owning a single vehicle. Airbnb runs the largest chain of hotels without owning real estate. Zomato is India's largest restaurant aggregator. What's the common thread connecting all of them? It's their deep reliance on data and artificial intelligence. These businesses are not just powered by technology, they're driven by intelligent systems that constantly learn from user behavior, make predictions, and adapt to change. This tells us something powerful. Data is the new oil, and machine learning is the refinery that extracts value from it. Artificial intelligence, AI, the big umbrella. Artificial intelligence is the science and engineering of making machines think, learn, or act intelligently, similar to humans. The goal of AI systems is to create systems that can perform tasks that typically require human intelligence. These tasks include decision making, problem solving, understanding language, recognizing patterns, and even creativity. Artificial intelligence has become an essential part of the modern economy. From personalized recommendations on Netflix to autonomous vehicles and real time fraud detection in banks, AI is everywhere. But what powers this AI revolution is machine learning. Machine learning is a subset of AI that enables computers to learn patterns from data and make decisions without being explicitly programmed for every scenario. Instead of coding rules manually, we feed the machine lots of data and it learns the rules itself. Key idea here is to take input data, use model that learns patterns in the data and makes predictions or decisions. Machine learning is what allows a voice assistant to recognize your speech or a recommendation engine to suggest the next best product. Deep learning is a subset of machine learning where models are built using artificial neural networks, structures inspired by the human brain. These networks have multiple layers. Deep means many layers, which allows them to automatically learn complex features and representations from data. Deep learning can handle very large data sets, millions of images, videos, and other types of data. We will be spending some time on this slide because this is going to give us really good understanding of what machine learning is. Let's begin by understanding what machine learning or ML really is. At its core, ML is a powerful subfield of AI that empowers computers to learn from data and improve their performance over time without being explicitly programmed. Think of it as teaching machines through experience. And when we talk about machine learning, we usually refer to four main types: supervised learning, unsupervised learning, semi supervised learning, and reinforcement learning. Supervised learning. The first and most widely used type is supervised learning. In this approach, we train the model using labeled data. That means the input comes with a correct output, like feeding the system questions and answers so it can learn the pattern. Now, supervised learning is further split into two categories based on the kind of output or target variable. Regression, when the output is continuous, like numbers. Classification, when the output is categorical, like labels or categories. Let's bring this to life with examples. In regression, a classic example is house price prediction. Given data like the size of a house, number of rooms, or location, a regression algorithm, say linear regression, can predict the expected selling price. Because price is a number, it's a continuous target. In classification, imagine medical imaging. Suppose we are given MRI scans and we need to classify whether the patient is healthy or has a specific disease. The result is either yes or no. That's categorical. So we use classification models like decision tree or support vector machines. Unsupervised learning. Moving on to the second type, unsupervised learning. Here, we work with unlabeled data. There's no correct answer provided, and the goal is to find hidden patterns or structures in the data. Unsupervised learning comes in two flavors: clustering, which groups similar items, association, which finds interesting relationships between variables. For example, customer segmentation is a classic clustering use case. Businesses can group customers based on behavior or demographics to personalize marketing. And market basket analysis is a great association example. Retailers analyze items bought together, like bread and butter, to optimize store layouts or promotions. Semi supervised learning. The third type is semi-supervised learning. This method combines both labeled and unlabeled data. It's especially useful when getting labeled data is expensive or time-consuming. In this hybrid approach, the system starts learning from a small labeled set and then generalizes to the larger unlabeled portion. Take text classification. If only a few emails are labeled as spam or not spam, a semi-supervised model can use those few labels to classify the rest. Or consider lane detection using GPS data in self-driving cars. Only a few GPS routes may be labeled with exact lane information. But with the help of this small set, semi-supervised learning can identify lanes on a wide range of roads. Reinforcement learning. Finally, we come to reinforcement learning, or RL. This is where an agent learns by interacting with an environment. Think of it like training a dog. Actions are rewarded or punished, and the dog learns what works. There are two broad categories here: classification style decisions, where outputs are categorical; control problems, where the agent makes continuous decisions over time. Let's look at examples. For optimized marketing, reinforcement learning can help decide which ad to show a user to maximize engagement. The system learns from feedback, like whether the user clicks the ad. And in the world of driverless cars, reinforcement learning helps the car learn to make decisions, when to accelerate, stop, or turn, all through interaction and feedback from the driving environment. To summarize, supervised learning relies on labeled data and includes regression and classification. Unsupervised learning reveals hidden structures using clustering and association. Semi-supervised learning blends the two and is ideal for cases with limited labeled data. And reinforcement learning is all about agents learning by trial and error in dynamic environments. Each type of machine learning plays a vital role in solving different real-world challenges. From recommending movies, diagnosing diseases, optimizing ads, to enabling self-driving cars, ML is transforming how we live and work. We'll use a real dataset containing 5,000 records that simulates a retail customer base. This will help us to understand how machine learning approaches any real-world problem. You should be seeing the dataset on your screen. This dataset will be added to the video files, and also GitHub link will be shared from where you can download this. Before diving into analysis and modeling, let's first understand the dataset we're working with. This dataset, titled Customer Transactions Dataset, contains information on 5,000 customers and their recent purchasing behavior. Each row represents an individual customer, and the dataset includes the following key attributes: customer ID and name, unique identifiers for each customer; age and gender, basic demographic details; city and sign-up date, location and when the customer joined; annual income, the customer's annual income formatted as currency; spending, score, a numeric score reflecting customer engagement or spending intensity. Product category, the category of the most recent purchase. Purchase, amount, the monetary value of the recent purchase. Last purchase date, when the last transaction took place. This data set offers a rich mix of categorical, numerical, and temporal data, making it ideal for segmentation analysis, customer profiling, and predictive modeling. In the upcoming steps, we'll clean and pre-process the data, perform exploratory data analysis EDA to uncover trends and correlations, apply suitable machine learning algorithms on the business question we aim to answer. First, let's look at a simple analytics task summarizing customer demographics. We analyze average age, gender distribution, and income distribution by city. These insights help a business understand its customer base. The tools used: group by operations, descriptive statistics, and visualizations like histograms and bar charts. Let's get our hands dirty now. This is where we will write our code. Step 1. Import required libraries. Pandas for loading and manipulating tabular data. Matplotlib.pyplot for plotting. Seaborn, a statistical plotting library built on Matplotlib. Step 2. Load the dataset. I will read it from my D drive datasets folder. Reads the CSV file into a pandas data frame named df. Step 3. Set plot style. Applies a clean grid background to all seaborn plots for better readability. Let's now start with statistics computation. Average age calculates the mean age of customers. Gender distribution counts the number of male and female customers. Average income by top 10 cities finds the top 10 cities by customer count. Filters the data set to include only those cities. Groups by city and computes the average annual income. Sorts the cities by average income in the ascending order. Now we will create 3 plots in one figure. Creates a row of 3 side-by-side plots using subplots. Plot 1. Age distribution plots a histogram with a kernel density estimate of customer ages. Plot 2. Gender distribution plots a bar chart of male versus female customer counts. Plot 3. Average income by city, a horizontal bar chart showing average annual income in the top 10 cities. Adjust the spacing between subplots so nothing overlaps. Displays the complete figure with all 3 plots. This script gives a quick visual summary of customer age distribution. Gender balance. City-wise income patterns. It's a great starting point for EDA before diving into deeper analytics or model building. Visualizations like these are not just pretty graphs. They play a crucial role in generating business insights by making complex patterns in the data easier to understand. Let's walk through how each of these 3 plots supports data-driven decisions. Age distribution. Plot shows how customer ages are spread across the population. Where most customers fall, this helps in customer profiling, helps in defining age-based personas. If the bulk of customers are 25 to 35, promotions can be tailored to this group's interest. Product planning. A younger audience may favor tech gadgets, while older customers might prefer financial services or home goods. New market targeting. If there's a noticeable lack of customers in certain age groups, for example, teenagers or seniors, businesses can explore why and whether to target them. Gender distribution plot shows the number of male and female customers. Business insights. Campaign personalization. If one gender dominates, for example, 70% female, businesses may design gender-specific promotions or content. Product mix optimization. For a predominantly male or female base, certain product categories may need to be emphasized more. Detecting imbalance. A sharp skew could also suggest bias in marketing or outreach efforts, an opportunity to correct and diversify. Average annual income by top 10 cities shows the top 10 cities by customer count and their average annual income. Business insights like pricing strategy. Cities with higher income may tolerate premium pricing or exclusive services. Geographic segmentation. Marketers can create different offers for high income versus moderate income cities. Store expansion or service targeting. Higher average income cities with high customer volumes may be prime candidates for launching new stores, services, or loyalty programs. Now comes the machine learning part. Let's build a classification model to predict whether a customer will make a high value purchase, defined as over $1,000. We'll use features like age, gender, income, spending score, and product category. The target variable is whether purchase amount greater than $1,000. This falls under supervised learning algorithm as we have the labeled or the past data to tell us the pattern. We will be using classification model as we would like to predict either yes or no. Let's apply logistic regression, which is a regression model modified for classification, and also the random forest model for in this problem statement. We'll need to pre-process the data like scale features, encode categories, and evaluate our model using metrics like precision and recall. Let's import libraries. NumPy for data loading and numerical operations. Model selection.train test split for splitting the data into training and test sets. Label encoder converts categorical values into numerical format. Standard scaler normalizes the feature values. Logistic regression and random forest. Classifier, two machine learning algorithms. Classification report and confusion matrix for evaluating model performance. We have already loaded the data. Let's create target variable. Variable that we want to predict using the model, usually represented as y. We will add a new binary column, high value 1 if purchase amount greater than 1,000, 0 otherwise. This becomes the classification target. Next step is to encode categorical features. This is needed because machine learning models cannot work directly with text labels. Converts gender and product category into numeric codes. Next, select features and target. X as input features or columns used for prediction. Y target variable 1 we are predicting, which is high value. Next step is to perform feature scaling. Feature scaling is a data pre-processing technique that normalizes the range of independent variables or features in a data set to a common scale, ensuring they contribute equally to the model's learning process. It's crucial because many machine learning algorithms are sensitive to the scale of the input data, and scaling can improve their performance, speed, and accuracy. This will standardize numerical features to have mean equals 0 and standard deviation equals 1. Split data into training and test set. The training set is used to teach the model, while the testing set allows us to assess how well the model generalizes to new, previously unseen data. Let's split the data set into 70% training and 30% testing. Now time to train logistic regression model. Model will learn the pattern from the trained dataset and then makes predictions on the test set. Now train random forest model. This uses ensemble learning with decision trees for higher accuracy and robustness. Now time to print the evaluation report. Classification report includes precision. How many predicted positives are correct? Recall. How many actual positives are captured? F1 score, harmonic mean of precision and recall. Accuracy, overall correct predictions. Confusion matrix shows true, false, positives, negatives in a 2 by 2 matrix. This script helps determine which customers are likely to make high value purchases, how well each model can predict this classification, which features influence the outcome. Let's now take a moment to interpret how our models performed. We trained two models, a logistic regression and a random forest classifier, to predict whether a customer's transaction was high value. Looking at the results, both models are currently performing close to chance level with an accuracy hovering around 50%. The precision and recall are somewhat balanced, which means neither class is being overly favored, but the overall performance is still quite low. So, what does this tell us? It tells us that while the models are functioning, there's room for significant improvement. And that's an important part of the machine learning process. We rarely get perfect results on the first try. In real world projects, much of the value lies in how you refine your models. How can we improve? There are several things we can do. Feature engineering. For example, we could apply our FM analysis, recency, frequency, monetary, which is commonly used in marketing analytics to understand customer value. Balancing the data set. If the data is imbalanced, we can apply techniques like synthetic minority oversampling technique or undersampling the majority class. Hyperparameter tuning. Models like random forest have many parameters we can optimize, such as the number of trees or max depth, to improve performance. Improving models is a process, and these steps are just the beginning. It's where the real skill of a data scientist comes in. And speaking of data scientists, that brings us to our next topic: career prospects in data science and machine learning. The field is evolving rapidly, and the demand for professionals who can understand data, build models, and deliver insights is growing across nearly every industry. Whether you're looking to become a machine learning engineer, data analyst, or AI researcher, there's a rich landscape of opportunities ahead. So, why pursue a career in data science? It combines high demand with lucrative salaries and versatile skills. It's impactful, cross disciplinary, future proof, and full of continuous learning. Whether you want to build models, manage data pipelines, or ensure ethical AI, there's a role for you in this space. To wrap up, machine learning is more than just a buzzword, it's a transformational force in business and society. And with tools and data sets like the one we saw today, anyone with curiosity and drive can become a part of this exciting journey. Hope you enjoyed this session. Hope to see you soon. Thank you.